Hey class, in today's lesson we're going to talk about logarithmic functions and their graphs, which is found in section 3.2 part 1. Our objective is to recognize and evaluate logarithmic functions with base A. Alright, so the definition of a logarithmic function. So it says the inverse function of the exponential functions is the logarithmic function. For x is greater than 0 and 0 is less than a but doesn't equal 1, y equals log base a of x if and only if x equals a to the y power. So the function f of x equals log base a of x is called the logarithmic function with base a. So if that is the case, I'm going to give you something a little bit easier, a little bit less mathy. And so we will call that log is bay. So if I call it log is bay, hopefully you can remember this. So log is log with a base and the answer, and it generally equals the exponent. Okay, so when we see this is the log form. Okay, the exponential form, because we will write them backwards and forwards, the exponential form will be what we saw here with that x equals a to the y, except we will say it is base, right, for base of the exponent, raised to the exponent equals the answer. Okay, so just writing them backwards and forwards, we'll see what we get on the next screen. So let's take a look. Knowing that log is bay, we should be able to write this correctly. All right, so we need to evaluate each expression, but you cannot evaluate. So we can't evaluate in log form. So if we can't evaluate in log form, then that means we have to change it from log to exponential form, and then we can solve it that way. So remember, if log is bay, that means that 2 is my base, 32 is my answer, and we're seeking the exponent. The goal is to figure out what exponent this is. So if I write this in exponential form, it's really 2 to the exponent equals 32. So just ask yourself, 2 to what power gives you 32? Well, x would have to be 5 because 2 to the 5th power equals 32. Okay? Let's check out the next one. Again, 10 would be our base. 1/100th is our answer, and again, we're looking for the exponent. So if I write this out, I should have 10 to some exponent equals 1 over 100. Well, it's helpful if I write 1 over 100 in the form of a power. So 1 over 100 is really 10 to the negative second power. And since these two numbers, 10 and 10, have the same base, right, then their exponents must equal the same. Okay, so then that means that as our answer, x equals -2. All right, then the last one, log base 3 of 27. Again, 3 is the base, 27 is the answer. Again, we're looking for the exponent. So if I write that correctly, that'd be 3 to the exponent equals 27. So 3 to what power gives you 27? Well, x will have to equal 3. 3 to the 3rd power gives us 27. All right, let's do a couple of tries. All right, so again, following that same format, this would be then 3 to some exponent equals 1. That may feel super unfamiliar to you, but remember, if you have a power, what power would any base have to be set equal to where the answer equals 1? Hopefully you should remember that if I set 0 as my exponent, any exponent anytime, it will always equal 1. So to answer our question, x equals 1. Or excuse me, 0. Okay? The next one, 4 to what power equals 2? 4 to what power equals 2? Well, that one's kind of confusing. What we're going to try and do first to be able to answer this better is to create a common base. So 2 and 4, as far as powers go, they do share a common power, and that power is 2. So 2 is already written as 2, but 4 is really 2 squared. Okay? And if I multiply this 2 and 2x, it becomes 2 to the 2x equal to 2. Now that they have the same base, and by the way, this is 2 to the first, I can ignore their bases and focus on their powers to solve for x. So now I have 2x equal to 1. If I divide by 2, x equals 1/2. So 1/2 is the power for that x value. And then the last one, it says 2 to some power equals 2. Obviously, they have the same base. 2 as a power is 2 to the first. So our answer is x equals 1. All right, let's keep moving. All right, so it says a logarithmic function with base 10 is called the common logarithmic function. So this is kind of like our common log. On a calculator, this function is denoted by the log button. So whenever you see the log button on your calculator, that's actually, again, if you see the log button on your calculator, that's really log base 10. So without us having to write log base, it's always log base 10. And using log base 10 is pretty popular. So for this is literally just a calculator function. So if you type log base 10 of 10, you should get 1. We could have done that one by hand. Also, reminder, 10, it was 10 to some power equals 10. Okay, my pen is not working. Okay, so again, we still would have gotten x equal to 1. On this one, though, the second one, you could not do that. So you would need to do this one on the calculator, and you get about 0.796. And the last one does not exist. And if you're wondering why, it's because 10 to some power has to equal negative 2.5, but no power will ever give you an answer that is negative, so it just does not exist. All right, here are some properties that you need to know. Log base a of 1 equals 0 because a to the 0 power is 1. That's that exponential, that's log form versus exponential form, okay? Just switching them back and forth. Log base a of 1 is 1 because a to the first power is 1. Log base a of a to the x is x. And a to the log base a of x is also equal to x. And that's just the inverse property. More so if I could show you, it's because these a's will cancel and leave you with x equal to x. And same thing here, a and log a will cancel to give you x equals x. Not the best way of showing you that, but essentially that's the understanding behind it. Okay, and then the last one, if log base a of x equals log base a of y, then essentially x and y must be equal, and that's the one-to-one property. So let's look at example 3. In example 3, we're going to solve the equation for x. So if I have log base 2 of x equals log base 2 of 3, essentially because they have the same log base, then these numbers are the same. So x equals 3. There was no work to be done. You just had to look for it. Okay. And then we'll do try 3. And it says log base 4 equals x. So again, if I use my exponentials, then say that log is bay. So then 4 to this exponent equals 4. Well, if they have the same base, then you just focus on their power, so the answer is x equals 1. And again, I also could have used one of our properties that we just saw to do that as well. All right, guys, we are done with this lesson for today. If you have any questions, please be sure to come see me for tutoring.